I'm Matt Stanley and I'm responsible for sales and marketing of our analytics solutions here at FICO. I'm joined again today by Andy Flint, who leads product management for our modeling solutions. In our last discussion, you gave a nice overview of Model Builder's capabilities, and one of the things that we touched on were real-world data issues. And I remember back in grad school receiving data sets to model on that were just perfect and were very easy to model on. When I arrived here at FICO, I realized that real-world data is quite a bit messier. How does Model Builder help the analyst handle real-world data?
Yeah, you're right, Matt. Real data is messy. Even in well-structured data sets, you're going to have missing values, you're going to have aberrant or outlier values, you're going to have exceptional values that don't really belong in the normal scheme of things. So the single most powerful tool in Model Builder to help deal with all of these is really the binning structure. And from one convenient screen, I'm able to cope with missing values. I'm able to cap outliers to prevent against over-leveraged points. I'm able to model directly any exceptional values that occur in my data. And I can even use that same interface to aggregate categorical variables, so I can model off non-numeric data right as easily as everything else. There are other forms of messy data as well, sort of unstructured things. And for those, we have other algorithms like our data spiders for transactional analytics and our text mining and our semantic scorecard to deal with text.
Does Model Builder have a similar set of tools for handling messy or missing target variables?
In originations modeling and response modeling, we almost always have this phenomena of missing targets or missing performance. And so we need some kind of technique to help put back that information so we can create a responsible model.
Another thing I recall was a strong emphasis on linear regressions and numeric data. In the real world, these patterns don't persist, and very often these simplistic assumptions don't hold up.
Right. Linear regression and logistic regression are both terrific academic foundations for data science, but they really impose these demands on the data that just aren't practical. The data have to be independently distributed, and you can't have multicollinearity in there, or those algorithms start to fall apart. So that's why we're such a fan of the generalized additive model that lives at the heart of our scorecard technology. Our ability to bin each variable and independently fit weights across all of the steps of that characteristic function let us create nonlinear fits of the data. They allow us to constrain things in monotonic patterns if we need that for our decisions. And they allow us to extract very reliably a strong signal from the data that yields a robust model.
One of the trends we've all seen over the past 20 years is that data sets are getting bigger and bigger. Here at FICO, we model on some truly massive data sets, and we know that our clients do the same. What capabilities does Model Builder have to help the analysts handle massive data sets?
With Model Builder 7.4, we introduced an integration with Hadoop and to take advantage of the distributed file system of Hadoop and its natural MapReduce paradigm for programming. So now in Model Builder, we're able to process the largest data sets, and we measure those times not in weeks and not in days, but just hours and minutes. And it makes us able to interrogate enormous data stores.
We've talked about how Model Builder handles missing values, special values, nonlinear data, and massive data sets. What's the net impact to the analyst of using Model Builder, which has all these capabilities?
It really allows our users to build better models and do it in less time. They've got reliable algorithms that scale to very large sizes. They've got great signal detectors that they can extract all the predictive power out of the data, and they can document everything they do along the way and rapidly deploy it into decisioning systems.
And those productivity gains are vital as we're all being asked to do more with less. One of the trends that we talked about today was the advent of big data, larger and larger data sets being used to model. One other important analytic trend that we've seen is the advent of text analytics, where analysts are now being asked to extract signal from text. We'll cover that in our next discussion.